Hello students, welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. So 8th class, right? Students, in the previous class we are completed a chapter solution, right? So that was a very important chapter and some numericals were there, and hope you understood that and you are practicing that chapter, because it's a very important chapter in terms of JEE Mains and advanced, because this is one of the most important chapter because it consists of numericals, right? Chalo. So today I am going to start one more important chapter, that is mole concept and stoichiometry. What is that? Mole concept and stoichiometry. So students, here mole concept and stoichiometry. This also very important chapter, and so your basics of this chapter, I think it is there in your CBSE syllabus in the 9th class, okay? But we are going beyond that, right? So listen carefully now. Stoichiometry and mole concept. Mole, did you hear this word? In chemistry, not in English. Yes. So here I think in the physics also you have come across the word called mole, where in units and dimensions, right? So here mole is a SI unit of quantity of matter, right? So there are 7 fundamental units are there, which you might have learnt in the physics, right? So mass, temperature, all are there, no? So in that term, one of the physical quantity is quantity of matter. So the SI unit of the physical quantity of matter, the quantity of matter is mole, right? Acha, so before going to that, first let us see once again about the small introduction. See students, chemistry, you know, any matter is made up of tiny particles called atoms, right? And atom constitute to form the molecules. Molecules combine to form the compounds. Like this, so many things are there, right? So here atom is there. So atom is a matter. So matter means what? Which has a mass and occupy the space, right? So here, how can we measure the mass of the atom? Because atoms are very small. Actually, you cannot see. Even through the microscope also you cannot see. Such a smallest particle is the atom. So how can we measure the atom, right? So the measurement of the mass of an atom is atomic mass unit. What it is? Atomic mass unit. So students, here the mass of an atom is measured in terms of AMU, means what? Atomic mass units. Okay, and or nowadays it is also called as a unified mass. What it is called? A unified mass. So here mass, generally in the chemistry we don't measure in terms of like kgs, grams and something like this, but we measure the relative atomic mass. What we measure? Relative atomic mass, ROM. Okay, so ROM indicates what? Relative atomic mass. All right. So what is this relative atomic mass? So relative means what? Comparison. Comparison is called relative, right? Relative atomic mass means what? The mass of an atom we are comparing with some standard one, okay? So what is the standard one? The standard one to measure the atomic mass is taken as carbon atom. What? Carbon. So carbon atom is taken as a standard one to measure the atomic mass, right? And it is taken that the carbon, the isotopes of carbon will be available. So, you know that what are the isotopes? Atoms of the same element having same atomic number but different mass numbers are called isotopes. So, carbon has isotopes, right? But in that term, we take the one stable isotope of carbon, that is C6 and 12. Okay. So, what here it 6 represent? 6 represent atomic number Z. A represent atomic mass, that is 12. So, we take this carbon whose atomic mass is 12, right. So, this is the stable isotope of carbon. Now, what we do is we compare the mass of any atom with the mass of this carbon. Okay. So, how? So, what we do is, here what the scientists decided is, the carbon isotope 6 and 12 mass is taken as 12 units. How many units? 12 units. Okay. So, 12 units whose mass, carbon atom mass is taken as 12 units, right. Now, if we divide this by 12, okay, so you will get to 1 unit, right. So, if you divide the mass of the carbon, by 12, okay, by 12, then whatever the mass you will get, that is considered as 1 AMU, 1 atomic mass unit. Is this clear to you? Okay. The standard one is taken as carbon atom. Which carbon atom? Carbon C12, right. And this carbon, this isotope's carbon mass is taken as 12 units. Okay. And what is a 1 unit? If we divide the mass of this carbon by 12, then we can get 1 AMU. Okay. So, this 1 AMU is taken as standard one, and in terms of this 1 AMU, we can measure the mass, we can compare the mass of other elements with this AMU. For example, if I compare the hydrogen mass, this hydrogen mass, okay, is equal to approximately, not exactly, approximately 1 AMU. 1 AMU. The meaning is what? If I divide the mass of carbon, the mass of carbon 612 divided by 12, then what I will get? That is equal to the mass of hydrogen. So, atomic mass of hydrogen is approximately 1 AMU. So, 1 AMU means what? Which is equal to the 12th part of the mass of carbon, is equal to 12th part of the mass of the carbon. Now, for example, if I take the helium, helium atomic mass is approximately 4 AMU, So, what is the meaning of 4 AMU? So, the meaning of 4 AMU is, okay, it is the, so mass of carbon, so mass of carbon 612 divided by 12 into 4 if I do, that comes to 4 AMU, right. So, because carbon atomic mass is taken as 12, right. So, 12 by 12, 1 into 4, 4. So, I will get the 4 AMU. So, we are comparing the mass of the helium with the 1/12 of the mass of the carbon, 1/12 of the mass of the carbon. So, then it is equal to 4 times the mass of the helium is equal to approximately 4 times of 12th part of the carbon's mass, right? Similarly, if we take the lithium mass is approximately 7 AMU. The meaning is what? Here the mass of the carbon, okay, the mass of the carbon divided by 12 into 7. So this is the, then it comes 7 AMU. The meaning is what? The mass of the lithium, when you compare, mass of the lithium is a 7 times of the 1/12th mass of the carbon. 7 times of 1/12th of the mass of the carbon. Clear? So try to understand this one once. Right? So here carbon is taken as a standard one. Similarly, calcium. So students, already I think that what's the atomic mass of calcium? 40. So the meaning is what? So this into 40. So just like that. Okay. So here generally, so I said, approximately. Okay. So that's what generally what we do is, it may be little more or less, okay, than the whole numbers, but we consider, mostly we consider, okay, the masses will be taken in terms of whole numbers only. Okay. So for example, if you see the page number 51 in your material, okay, there is a list of first 30 elements. This already we discussed. Okay. The atomic numbers, electronic configuration, mass numbers, I said you to already in the during the volume 1 only, to learn the atomic numbers, mass numbers, symbols, electronic configuration of first 20 elements. Okay. The same thing is given in your textbook, page number, material, page number 51. So here hydrogen 1, helium 4, mass numbers. Okay. Lithium 7, beryllium 9, boron 11. This already you know. Okay. So this is about the, these are the mass numbers of this first 30 elements are given. Okay. But here if you see only mass number, means if you take the mass number, there is no particular units for the mass number. Okay. So what is the mass number of hydrogen? We just you say 1. What is the mass number of helium? We say 4. What is the mass number of sodium? We say 23. What is the mass number of calcium? We say 40. But if we express this mass in terms of grams, that's called gram atomic mass. What is called? Gram atomic mass. Okay. Or we can say simply gram atom. Okay. Gram atom. So the meaning is what? For example, lithium. Okay. So if I take the lithium, okay. So here atomic mass of, means in terms of, if I express the lithium atomic mass in grams, then we can say that lithium is equal to 7 grams. What we can write? 7 grams. So 7 grams of lithium. What this 7 grams of lithium indicates? 1 mole of lithium weighs 7 grams. Okay. The weight of 1 mole of lithium is equal to 7 grams. Okay. So similarly, for example, if you say 1 gram of hydrogen, 1 gram of hydrogen means what? Here the mass of 1 mole of hydrogen, 1 mole of hydrogen is equal to, okay, the mass of 1 mole of hydrogen is equal to 1 gram. Right. Now what is the helium atomic mass? 4. Okay. So 4 grams of helium means the mass of 1 mole of helium, the mass of 1 mole of helium is 4 grams. Similarly, for example, the mass of 1 mole of oxygen, if I ask, then what do you say? the mass of 1 mole of oxygen is 16 grams. Why 16 grams? Because the mass number of oxygen is 16. Did you understand now? So, the mass number, if we express in grams, mass number, if we express in grams, that is the mass of 1 mole of that particular element. Is this clear to you? Okay. So, that is about the atomic mass. So, students, here atomic mass, if you are expressing in grams, that is equal to the 1 mole mass of that particular atom. Okay. So, for example, if I ask you what is a 1 mole of, what is the mass of 1 mole of calcium? So, simply you can say what is the mass number of calcium? 40. So, the 40 grams of 40 grams, okay, is the mass of 1 mole of calcium. Clear to you? So, that is for atoms. That is for what? Atoms. So, if you see the page number 51, you have a list of the 30 elements, right? So, mass numbers are given, you see here once. For example, nitrogen. Okay. So, nitrogen mass number is what? 14. So, if anyone asks you what is the mass of 1 mole of nitrogen atom in terms of grams, just you see that what is its mass number? 14. So, 14 grams of nitrogen or 14 grams, okay, is the mass of 1 mole of nitrogen atoms. Clear? Very simple, no? So, 1 mole of any substance, if you want to express the mass of 1 mole of any substance or any atom in terms of grams, just you put the grams beside of its mass number. Very simple. Okay. For example, if I ask you what is the, come on, you see the answer now. What is the mass of 1 mole of sulfur atoms? Come on, say now. Very simple. What is the sulfur atomic mass? Mass number 32. So, 32 grams is the mass of 1 mole of sulfur atoms. Clear, no? Okay. That is for atoms. Then about the molecules. So, see here, there is a very important thing you have to remember. If you know that oxygen atomic mass is a 16. What is the oxygen atomic mass? 16. Okay. If I ask you what is the one mass of mass of 1 mole of oxygen atoms. Oxygen atoms. And similarly, if they ask you what is the mass of 1 mole of oxygen gas, difference, what you find the difference here? 1 mole of oxygen atoms, 1 mole of oxygen gas. Does this both represent same? No. Why? Here this is oxygen atoms. And when you want to represent the oxygen gas, then we have to write the O2. Okay. Oxygen gas is what? O2. Right. So, 1 mole of oxygen atom, mass of 1 mole oxygen atom is, oxygen atomic number is how much? 16. 16 grams. 16 grams. This is right. Okay. If they ask you what is the mass of 1 mole of oxygen gas, so oxygen gas is O2. 2 oxygen atoms combined to form the oxygen gas. So, here O2, each oxygen atomic mass is 16. So, 16 to the 32. So, 32 grams. Okay. 32 grams. What is 32 grams? The mass of 1 mole of oxygen gas is equal to 32 grams. The mass of 1 mole of oxygen atoms is equal to 16 grams. So, here oxygen is what? It's not an atom, but it's a molecule. What it is? A molecule. Molecule means what? When atoms combine, that forms a molecule, right? So, this is called gram molecular weight. What it's called? Gram molecular weight. If you are expressing the mass of a molecule in terms of, okay, in terms of grams, then that's called a gram molecular weight. If you are simply expressing, then that's called molecular weight. Simply if they ask you, what is a molecular weight? Molecular weight of oxygen. Then you write simply 32, because each oxygen atomic mass is 16. 16 2s are 32. So you can write 32. If they ask you to express in terms of grams, then you can write 32 grams. Clear? Any doubt? Yes? Okay, one more. Now you try now. Mass of 1 mole of nitrogen atoms is equal to, similarly, mass of 1 mole of nitrogen gas. Come on, you say now. In terms of grams. Okay. So, mass of 1 mole of nitrogen atom is how much? Very good. 14 grams. Why 14 grams? Because each the atomic number or mass number of nitrogen is 14. So, 14 grams is equal to 1 mole of nitrogen atoms. Then what is the mass of 1 mole of nitrogen gas? 2 nitrogens are there. So, nitrogen each is 14. 14 2s are 28. So, 28 grams. Clear? Okay. So, like this. So, that is the difference between the molecular mass and the atomic mass, right? Molecular mass, atomic mass. Is this clear? So, this is till now we discussed all these things, right? So, now the question rises that, sir, you are telling that mass of 1 mole of nitrogen atoms is equal to 14 grams. Mass of 1 mole of nitrogen gas is 28 grams. Everything is fine, sir, but what is mole? Already said that mole is the SI unit of quantity of matter, right? But how can I understand? So, students, here you have to remember one important point here. That most important point is that 1 mole of any substance, 1 mole of any substance consists of 6.023 into 10 to the power of 23 entities. I am writing just entities. Okay. So, the meaning is what? 1 mole of oxygen atoms, if anyone asks you. So, 1 mole of oxygen atoms consists of 6.023 into 10 to the power of 23, right? Atoms. If I ask you 1 mole of hydrogen atoms is equal to how many? See, so 1 mole of hydrogen atom consists of 6.023 into 10 to the power of 23 atoms. So, 1 mole of calcium. 1 mole of calcium also consists of 6.023 into 10 to the power of 23 calcium atoms. So, 1 mole is nothing but this number is fixed, 6.023 into 10 to the power of 23. So, are you confused? Why confusion? See, for example, if you go to the shop like banana shop, okay. So, if you go to the banana vendor and I ask just 1 dozen of bananas you want. So, you ask 1 dozen of banana. How many bananas will he give to you? 12 bananas, because 1 dozen is equal to 12, right? Okay. Now, you go to the another shop where, for example, apples are there. And if you ask him to give 1 dozen of apples, so how many apples will he give? Again 12 only. If you go to the shop of pomegranate, okay, and if you ask you 1 dozen of pomegranates you want, how many will he give? Again 12 only. So, 12 is what? A dozen. Dozen means what? 12. So, if you go to the banana shop and if you ask 1 dozen of bananas, 12 bananas, 1 dozen of apples, 12 apples. 1 dozen of pomegranates, 12 pomegranates. Yes, right. So, dozen represents what? 12, that is a number. Similarly, mole also represents a number. Mole also represents a number. That number, 1 mole is equal to 6.023 into 10 to the power of 23. This is a fixed number. So, if you want to express the number of atoms, okay, for any mole that is fixed, that is 6.023 into 10 to the power of 23. That is fixed. Okay. So, sir, you said that 1 mole mass of 1 mole of oxygen, okay, atoms is equal to, for example, oxygen about 16 grams, and mass of 1 mole of, for example, sulfur is equal to 32 grams. Okay. Then how is it possible? Yes. So, yeah, 1 mole means what? 16 grams of oxygen consist of 6.023 into 10 to the power of 23 oxygen atoms. Okay. And 1 mole of sulfur atom is equal to 32 grams, means 32 grams of sulfur if we take, that consists of 6.023 into 10 to the power of 23 sulfur atoms, like this. Okay. So, here if you take 6.023 into 10 to the power of 23 oxygen atoms, its mass equal to 16 grams if you are expressing in the grams. If I take same number of 6.023 into 10 to the power of 23 sulfur atoms, and that is equal to 32 grams, right? Number same, but mass will be changes, yes or no? For example, if you take 1 dozen of bananas and measure its weight, and take 1 dozen of apples and again check the weight, does they both remain same? No, bananas weight is different, apples mass is different. That is, apples are different, bananas are different. Here also oxygens are different, sulfurs are different, sulfur is different. Is this clear to you? So, in that way, we can calculate the, okay, atomic mass or molecular mass of any substance, okay, in terms of grams. Is this clear to you? Okay. So, students, so we'll do one thing today. Today with this I'll stop the class. So, today's your work is what? 1 to 30. Already we discussed 1 to 20 in the previous class only, in the starting. All elements, the atomic numbers, symbols, mass numbers, everything. So, today 1 to 30 elements is given in the page number 51, right. So, these all atomic masses means elements, symbols, atomic numbers, mass numbers, learn perfectly. So, in the next class, we are going to calculate the gram molecular, it's already calculated. This also we already learnt gram molecular weight in the solutions chapter. Okay, in the solution chapter also we calculated, but okay, once again in this chapter it's given, it's a very important topic. So, once again we tomorrow means in the next class we start, we do some calculations to measure the molecular weights of some molecules. Okay. So, that may be homoatomic or heteroatomic, okay, different types of atoms, atomic masses, molecular masses we measure, and we try to express them in terms of grams, and okay, we complete this first synopsis of mole concept. Okay. So, it's a very important chapter, students. So, listen carefully and practice. For this chapter also practice is required. Just by listening or reading is not enough. Okay. Bye. Take care.